Have you ever made a choice and wondered, what if I'd done the other thing? What if, in another reality, a different version of you actually did? This isn't just science fiction. It's a mind-bending concept from modern physics called the multiverse. Today, we're diving deep into the science behind parallel universes. Is it possible that countless other versions of our reality exist right alongside our own? First, let's get one thing straight. The multiverse isn't just one single idea. It's a collection of different theories, each proposing a unique way that multiple universes could exist. We'll explore the most popular ones, starting with the quilted multiverse. Imagine space is infinite. If it goes on forever, then eventually, everything that can happen must happen. Statistically, in a vast enough space, the arrangement of particles will eventually repeat. This means that somewhere out there, unimaginably far away, there's another region of space identical to our observable universe. A patch in the cosmic quilt that looks just like ours. And if there's one, there are likely infinite copies. Some identical, some slightly different. In one, you might have chosen cereal for breakfast instead of toast. In another, dinosaurs might still be roaming the earth. This isn't about magic. It's about probability playing out on a cosmic scale. This idea comes directly from our standard cosmological model. If the universe is flat and stretches on forever, as our best measurements suggest, then a quilted multiverse is almost an inevitable consequence. It's a staggering thought. Your exact double could be out there, living a parallel life, separated from you by an astronomical but finite distance. Now, let's travel from the infinitely large to the infinitely small, with the many worlds interpretation of quantum mechanics. This one is a real head-scratcher. In the quantum world, particles like electrons can exist in multiple states at once, a phenomenon called superposition. It's only when we measure them that they choose a single state. The many worlds theory, proposed by Hugh Everett III in the 1950s, suggests they don't choose at all. Instead, every time a quantum measurement is made, the universe splits. For every possible outcome, a new, separate universe branches off. Think of it like a constantly forking road. You flip a coin. In one universe, it lands heads. In another, it lands tails. Both outcomes happen, just in different, parallel realities. This means that from the moment you woke up this morning, you've been creating countless new universes. The universe where you hit snooze, it exists. The one where you jumped out of bed immediately, that exists too. According to this theory, there's an almost infinite number of yous living out every single possibility, big and small. It's a humbling and slightly overwhelming idea, suggesting that reality is a vast, branching tree of possibilities, and we're just living on one tiny twig. But wait, there's more. Let's talk about the brain multiverse. This idea comes from string theory, one of our leading candidates for a theory of everything. String theory suggests that our entire three-dimensional universe might be a membrane, or brain, floating in a higher dimensional space, called the bulk. Picture a single slice of bread in a loaf. Our universe is that slice, but there could be other slices, other brains, stacked parallel to ours in this higher dimension. These other universes could be just millimeters away, but we can't see or touch them because we are confined to our own brain. What's fascinating about this model is that it offers a potential explanation for gravity. String theory suggests that gravity might be the one force that can leak between these brains. This could explain why gravity is so much weaker than the other fundamental forces like electromagnetism. It's not weak. Its strength is just diluted across multiple dimensions and multiple universes. So, the next time you drop your keys, you can blame the gravitational pull of a parallel universe. Another mind-bending concept is the inflationary multiverse. This theory piggybacks on the idea of cosmic inflation, the period of rapid, exponential expansion the universe underwent just a fraction of a second after the Big Bang. According to this model, championed by physicists like Alan Guth and Andre Lind, inflation didn't just happen once. It's a process that's constantly happening, a kind of eternal inflation. Our Big Bang was just one event where inflation stopped in a small pocket of space, allowing our universe to form and cool down. But outside our pocket, inflation continues, spawning an endless foam of other bubble universes. Each bubble has its own Big Bang, its own expansion, and potentially its own unique laws of physics. In one universe, gravity might be stronger. In another, there might be 4 spatial dimensions instead of 3. The number of electrons might be different. This creates a cosmic landscape of incredible diversity. Most of these universes would be sterile and inhospitable to life as we know it, but with an infinite number of bubbles, it becomes statistically likely that some, like ours, would have just the right conditions for stars, planets, and eventually, life to America. It offers an elegant answer to the question of why our universe seems so perfectly fine-tuned for our existence. It's not that it was designed for us. It's that we exist in one of the few universes where we could. So, we've covered 4 major multiverse theories: the quilted, the quantum many worlds, the brain, and the inflationary. You're probably thinking, this is great, but is there any actual evidence? That's the billion-dollar question. As of now, we have no direct, verifiable evidence for the existence of other universes. These are theoretical models, born from the mathematics of our most advanced physical theories. They are predictions, not observations. However, scientists are actively looking for clues. For example, if our universe collided with another bubble universe in the distant past, it might have left a bruise on the cosmic microwave background, the faint afterglow of the Big Bang. Astronomers are scanning maps of this radiation for any telltale cold or hot spots that could be a sign of such a cosmic fender bender. So far, the search has been inconclusive, but the data is constantly improving. For the brain multiverse, experiments at particle accelerators like the Large Hadron Collider could offer clues. If they can create tiny, fleeting black holes or detect energy seemingly disappearing from our universe, it might be evidence of extra dimensions and gravity leaking away to another brain. The challenge is immense. By their very nature, these parallel universes are separate from our own. How do you test for something you can't see, touch, or interact with? This is the central philosophical and scientific debate. Critics argue that if a theory cannot be tested, it isn't science, it's metaphysics. Proponents counter that these theories are the logical extensions of our best-tested ideas, like quantum mechanics and general relativity, and we should follow the math where it leads. Regardless of whether we ever prove it, the concept of the multiverse forces us to reconsider our place in the cosmos. For centuries, we've been on a journey of cosmic humility. From believing Earth was the center of everything, to realizing it's one planet around one star, in one galaxy among billions. The multiverse is the next logical step in that journey. It suggests that even our entire universe might be just one of an infinite number. It's a concept that is both deeply scientific and profoundly philosophical. It challenges our notions of uniqueness and reality itself. The idea that every choice you didn't make is being lived out by another version of you is both comforting and unsettling. So, is the multiverse real? The honest answer is, we don't know. But the fact that our most brilliant scientific theories are pointing in this direction is incredibly exciting. It shows us that reality might be far grander, stranger, and more wonderful than we ever imagined. The quest to find out is what drives science forward. What do you think? Which multiverse theory do you find most compelling? Let me know your thoughts in the comments below. I'd love to hear your perspective on this cosmic mystery. Thanks so much for joining me on this journey through parallel worlds. If you enjoyed this mind-expanding trip, please hit that like button and subscribe for more deep dives into the biggest questions in science. Click the bell icon so you don't miss our next adventure. Until then, keep looking up and keep wondering.